Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So this is actually a continuation of the lecture video for subject electrical circuits 1 code BEV 10303. So in this video we are going to continue on chapter 2, which is basic law of electrical circuit. Okay, so in this video we are going to continue with the subtopics of parallel resistor circuits and the concept of current division. Okay, so now let's have a look. What does it mean by the parallel circuit? Okay, a parallel circuit is actually a closed circuit in which the current divides into two or more paths before recombining to complete the circuit. Okay, so basically this is your parallel circuit where you have a voltage supply connected in parallel with R1, R2, until your Rn. Okay, so you see the current will be divided into two or more paths. So here your I is actually the current that coming from your source. Okay, I is divided into I1, I2 and so on until your In. Alright, so this is your equivalent circuit for your parallel circuit. Alright, so from here you see that I is equal to I1 plus I2 plus until your In. So that one is according to your Kirchhoff current law lah, because your total of current that entering the node is equal to the total of current going out from the nodes. And then you can see as well the voltage drop across V1 is equal to V2 is equal to until your Vn. So this is the law for the parallel circuit. Okay, so the total conductance is actually equal to the sum of their individual conductance, where in this case G total is equal to your G1 plus G2 plus G3 and so on. And then the total resistance of your parallel circuit is equal to the product of their resistance divided by their sum. So it means that the R total is equal to R1 multiplied with R2 multiplied with R3 until your Rn divided by the sum. So R1 plus R2 plus R3 plus until your Rn. Okay. The voltage drop is the same across each of the parallel component. Okay, so your V1 now is equal to V2 plus equal to V3 and so on. And then the current through each of the parallel element are different because the current from your source is actually divided into each of the elements. Okay, so the current depends on the value of the R. And here you have In is equal to V. V is the voltage supply over your Rn. Okay. And then the power dissipation at each of the elements is given by PRN. You can either use IV or I squared R or V squared over R. And then the power dissipation at each of the elements also different because in this case, even though the V is remain the same, but I is different. Okay. So because I is different, so that's why the power dissipation at each of the elements also different. Okay. So again, the power supply by the source will be equal to the total power dissipation at each of the elements. So this law is applied for both parallel and the series circuit. Okay. Where your P total is equal to I multiplied with V. So I is a current from your source and V is a V source. Okay. So PR1 is actually a power dissipation at the resistor 1, power dissipation at the resistor 2, power dissipation at the resistor 3, until your Rn. Okay. Alright. So let's have a look at the following example. So this is your this is the given circuit. So based on the circuit, you need to determine the equivalent resistance. And then you need to determine the total current, which is your IT. IT is the current that coming from your supply before it divided into I1 and I2. And then you need to calculate the current through each of the resistors. So you need to calculate what is the value of I1, what is the value of I2. And then power dissipation at each of the elements and the total circuit power. Okay, so power dissipation at 5 ohm, power dissipation at 15 ohm. Okay, and then power dissipation by the total circuit. Okay, so you need to add on P1 and P2. Alright, and then you need to calculate the power supply by the source. So power supply by the 30 volt. And then after that, you need to give a relationship between the answer in 3 and the total current. So 3 current through each of resistor. So you need to relate I total with I1 and I2. and then give a relationship between answer in 4 and 5. So 4, you need to give a relationship between power dissipation at each of the elements with the power supply by the source. Alright. So how to answer this? Okay, again, you can just draw back your circuit. So where you have a supply of 30 volt connected in parallel with 5 ohm and 15 ohm. Okay, so RT in this case, RT is actually equal to R1 multiply with R2 divide R1 plus R2. Okay, so here R1 is 5 multiplied with 15 over 5 plus 15 equal to 3.75 ohm. Alright, and then next, IT. IT is equal to V supply over RT. So in this case, V supply 30 over 3.75 is equal to 8 ampere. So I total, which is I coming from the supply, is equal to 8 ampere. And then after that, you need to calculate I1 and I2. So in this case, you know, because it is connected in parallel, so V1 is equal to V2 equal to 30 volt. Alright. And then I1 now is, by applying the Ohm's law, I1 is V over R. So V1 over 5 ohm. V1 is 30. 30 over 5 is 6 ampere. And then I2 is equal to V2 over R2. So V2 is same as 30 volt. So 30 over 15 is equal to 2 ampere. Okay, so the relationship between I1, I2 and IT. So sum of the current through each of the resistor is equal to the total current supplied by the source. IT is equal to I1 plus I2. Okay, so that one is according to the Kirchhoff current law. Okay, so for power dissipation by each of the elements, so you can either use the formula of P equal to IV or P equal to V squared over R, P equal to I squared R. Okay, so in this case, I'm using P equal to IV. So I have P1 is equal to I1 multiplied with V1. I1 is given by 6. V1 is 30 volt. So that's why I have 180 watt. So P2 is equal to I2 V2. So in this case, I2 is 2 ampere. V2 it's same as V1, 30. So that's why I got 60 watt here. And then the total power dissipated by the whole circuit is given by P1 plus P2. So in this case, 180 plus 60 is equal to 240 watt. Okay. So power supply by the source. So for the power supply by the source, because of the according to the passive sign convention, if your current from is flowing from your negative to the positive side, so you need to use P equal to negative IV. So in this case, negative IT multiplied with V. So IT is equal to 8 ampere. Negative 8 multiplied with 30 is equal to negative 240 watt. Okay. So finally, the total power dissipated by load is equal to the total power supplied by the source. Okay. So here you have 240 watt. So here also you have 240 watt. Here negative sign meaning that the power is being supplied. Here you have a positive sign, so meaning that the power is being absorbed. Alright. So next we are going to see the concept of current divider rules for the parallel circuit. Okay, so again you are given a parallel circuit like this. Let's say you have a R1 parallel with R2 connected to the voltage supply in parallel as well. Then the equivalent circuit for this parallel circuit is given by this, okay, where you have RT is equal to R1 multiplied with R2 divide R1 plus R2. Okay, so next, based on the KCL, you know that for based on the KCL, the total of current that entering the nodes is equal to the current that going out from the node. So you have I is equal to I1 plus I2. And then when applying your Ohm's law, you know that I1 is equal to V1 over R1 and I2 is equal to V2 over R2, right? So this is considered as your equation number 2. Okay, so basically you can substitute your equation 2 into equation 1, where your equation 1 is I is equal to I1 plus I2. So from here, I is equal to V1 over R1 plus V2 over R2. Okay, and then I can rearrange my equation so that I have the same denominator. I have R1, R2 at the lower side. So what can I do? I can multiply this term with R2 over R2 and this term with R1 over R1. So finally, I can have V1 R2 plus V2 R1 over R1 R2. Okay. Based on the given circuit, you know that your V supply is equal to V1 equal to V2. So that's why here V1 and V2 I can substitute with the value of V. So I is equal to VR2 plus VR1 over R1R2. So what can I have here is I is equal to V multiplied with R1 plus R2 over R1R2. Okay, and then after that we can rearrange it so that we have V is equal to I multiplied with R1 R2 over R1 plus R2. Okay. Based on the equation that you get from the previous slide, V is equal to I R1 R2 over R1 plus R2. So this one we consider as the equation number 3. So how to find the value of I1 and I2? So by applying the Ohm's law, you know I1 is equal to V1 over R1, right? So based on that, we can substitute this equation into V1 over R1. So V1 is equal to V. V1 is equal to V. V is given by this. So I can just substitute the value of V over R1. So I R1 R2 over R1 plus R2 divided by R1. Okay. And then I can cancel R1 and R1. So finally I have I R2 over R1 plus R2. Okay. Same goes for I2. I2 is equal to V2 over R2. So V2 over R2. So V2 is equal to V. V is given by this. And then after that, I can cancel the value of R2 and R2. So finally, I have I R1 over R1 plus R2. Okay. So this is what we call as a current divider rule. Okay. So according to the current divider rule, when you want to find the value of I1, okay, I1 is equal to R2 divided by R1 plus R2 multiply with I. Okay. So when you want to find the value of I2 here, I2 is equal to R1 over R1 plus R2 multiply with I. I is the current that coming from the supply. Okay. So let's have a look following example. For the following circuit, find current for each element using the current divider rules. Okay, so you want to find the value of I1 and I2. So in this case, R1 is 15 ohm, R2 is 30 ohm. So solution to the question, again, you can just draw your circuit and then you need to find the value of I1 and I2. So before you can calculate the value of I1 and I2 by using the current divider rule, you must find the value of I first. Okay, so how to calculate the value of I? First, you need to calculate the value of RT, which is R equivalent. So R equivalent is equal to 15 multiplied with 30 over 15 plus 30. Okay, so the RT is equal to 10 ohm. And then after that, I can calculate the value I, where I is equal to V over R. So V is 12 over R is 10. So 12 over 10 is 1.2 ampere. Okay. So once I find the value of I supply, which is I is equal to 1.2, I can just use the current divider rule. Okay. So I1 is equal to R2 over R1 plus R2. Okay, so R2 is equal to 30 over 15 plus 30 multiplied with 1.2. So I get 0.8 ampere. So for I2 is equal to R1 divided by R1 plus R2. So R1 is 15 over 15 plus 30 multiplied with 1.2 here. So finally, I2 is equal to 0.4 ampere. Okay, so that's how you use the current divider rule to find the value of I1. Okay, and I2. So that's all for now. Thank you for your time. Thank you for watching my video. I'll see you in my next video. Okay, bye.